Welcome back to Physical Science 20. So this is the FC2.4 molar volume, in which we'll perform molar conversions including volume to mole and vice versa using the correct number of sig figs. So molar volume, so Avogadro's law, which we don't take but we should mention it here, tells us that if I have equal volumes of gas at the same temperature and pressure, they contain equal numbers of mole particles. So incorporating that, we can understand that 1 mole of chlorine gas and 1 mole of methane, under identical conditions, have the same volume. So 1 mole will correspond to a specific volume. The molar volume is the volume occupied by 1 mole of any gas, and it's the same for all gases. So we look at 2 different scenarios, because there could be multiple temperatures, multiple air pressures that we could look at. So we kind of narrow it down to 2 scenarios. One is referred to as STP conditions, and it occurs at when the temperature is 0 degrees and a pressure of 101.325 kilopascals. Another scenario deals with SATP, which is 25 degrees C and 100 kilopascals. So 1 mole at any gas at standard temperature and pressure. So standard temperature, pressure, that's where the STP comes from. It occupies 22.4 liters. And 1 mole of any gas at SATP, which is standard ambient temperature and pressure, occupies 24.8. Okay, so here are some visuals here indicating 1 mole of gas at STP. So 1 mole, so the same number of particles in each, and they occupy 22.4. We're making conversions among the amount, mass, and volume of the gas. Remember to note whether it's SATP or STP. So if you look on your blue sheet, there's a couple of things we can add here. So we have this one on here. We have the STP conversion. So we have 22.4 liters is 1 mole, or 1 mole is 22.4. We need to add the volume of gas at SATP conditions. So we're just going to add that in there. Let me remove my sheet so we can see that. And so going from moles to liters, of course we said that was 24.8 liters is 1 mole. Okay, and then going back this way, 1 mole is 24.8 liters. So those are the 2 conversions. So we have our 2 conversions here, 2 conversions here. And we could also add something else here. And again, put this on your blue sheet or your mole conversion sheet. With SATP, we're talking about 25 degrees C and 100 kilopascals. Because I could just give you the conditions and you'd have to figure out, oh, it's at SATP. And over here it's 0 degrees C and 101.325 kPa or kilopascals. So you may want to write that in there, just so we know the 2 conditions that we're going to be dealing with gases. All right, so on the flip side, we can look at a couple of examples. We'll see it's fairly straightforward. The key, of course, is to figure out what scenario we're dealing with. So a party balloon has 2.5 moles of helium gas at STP. What's the volume? So we're going to volume, which is in liters, and we're told we're doing it at STP. So we have to go back and look at STP. So we're going from moles to volume at STP. So yes, we can see we're going to multiply by 22.4 liters for every mole. So 2.50 moles of helium. And for every 1 mole of helium or any gas, it's 22.4 liters. Okay, so of course we know if we're doing it right, if we can cancel, we'll get our final answer of liters. So I think it works out 56.0 liters of helium. And of course, 3 sig figs, 3 sig figs. All right, so look at this one. So again, we'll look at helium, SATP this time, and we have a mass of 32 Gs. What volume is that? So on our chart, we know we can go from moles to liters at SATP conditions, but we're given grams. So yes, this will be a two-step conversion because we're starting off with mass in grams. Then we'll have to figure out liters, and then we'll have to figure out, mass to moles, and then to liters in SATP. So we have to figure out the molar mass of helium. We need to know that, of course, and that's 4.0 grams per mole, just looking off the periodic table. So 32.0 grams of helium, and we know that for every mole of helium, we have 4.00 grams of helium. So if I was to stop there, I'd be at the mole step. Of course, we have to go one more step to get to liters. And we know that 1 mole of any gas at SATP is 24.8 liters. So right here, 24.8 liters when going in that direction. Of course, cross that out and we're left with liters of helium. We worked that out. I think your calculator says 198.4 liters of helium. But of course, we got 3 sig figs, 3 sig figs. This is a 4, so that just simply stays as 198 liters of helium. What about vice versa? So a container of oxygen gas has a volume of 145.6 liters. If the pressure of the gas is 101.325 kilopascals and 0 degrees C. So 101.3 and 0. Let's see, 101.3 and 0, we're talking about STP conditions. So that's an example in which I give you the conditions. These don't get involved in the calculation, but they tell us what one to use. Determine the number of moles. So I'm going to go from liters to moles, and of course it's in STP. So let's see, 145.6 liters, and let's see, STP. So we're going from liters to moles, 1 mole over 22.4. 1 mole over 22.4 liters. Let's cancel, cancel. And I think we get 6.500 moles. And this was actually, oh yeah, oxygen gas. So I could put O2 here, O2 here, O2 here. And of course, the reason why I have so many zeros there, 1, 2, 3, 4, 1, 2, 3, 4. So I need to have 4 sig figs to make that work. All right, so that's it. That's FC2.4 molar volume. Should be able to do the assignment and check your answers, and we'll see you again.